This is Mr. Nabi from Roger Bacon High School. Today's video for AP Calculus is on derivatives. As you take a look at the note sheet that we have organized here, the concept of a derivative is defined as the limit of f of a plus h minus f of a all divided by h as h approaches 0. And this is the limit formula that we talked about as the secant slopes become a tangent slope. In other words, as the average rate of change moves closer and closer to an instantaneous slope, an instantaneous rate of change. So all these terms are synonymous: instantaneous slope, slope of a tangent line, and derivative. They all mean the same thing. And we're going to look at a couple of different rules for calculating derivatives. Actually, there are 4 rules today. And the first is the constant rule. And if you think of f of x as being equal to some constant c, then the rule for the derivative, or f prime of x, is that the derivative of a constant is 0. Now this is the only one we're going to look at in more detail, but as an example, we can say that f of x equals -3 perhaps. So let me use a different color here, and I'll draw in f of x equals -3. So there's -3. And clearly, if you were to calculate the slope of this line, it has a rise of 0 and a run of some real number other than 0. So the slope would be 0 because it is a horizontal line. So we know that f prime of x must be 0 because of the constant rule. And that makes sense to us because the instantaneous slope, the slope at any point on this blue line, would always be 0. We can go to the next rule, which is known as the power rule. And if I have f of x equals x to the n, x to some variable, the power rule says that the derivative of that is simply n times x to the n minus 1. Now let's look at a few examples. Suppose I have x to the 5th. If I want to take the derivative, I can simply move the exponent out front as the coefficient, and the rule tells me to reduce the power by 1. So 5x to the 4th would be the derivative for f of x equals x to the 5th. And I could evaluate that formula for the derivative for any value of x. Let's do another example. Let's try f of x equals 3x to the 6th. That must mean that f prime is, again, taking the exponent out front, 3 times 6 is 18, and reducing the exponent by 1, 18x to the 5th. And one final example, if f of x is equal to 2x cubed plus 3x plus 4, then the derivative is simply, using the power rule for the first term, 6x squared. The power rule for the second term, well, the second term has a power of 1, so it's just 3 times x to the 0, and we know that x to the 0 is always 1. Anything to the 0 is 1, so that's just 3. And then we've got a constant term at the end, and we knew from the past example that the derivative of a constant is 0, so it's actually just 6x squared plus 3. The next formula I want to talk about is the product rule. And the product rule applies to any function that can be written as the product of 2 other functions. So if I want to find f prime of x, and I'm using g of x and h of x as my 2 values, I can simply do the derivative of g times h plus the derivative of h times g. So that's the rule. Let's look at an example. Our first example will be 3x plus 1 times x squared plus 4x. So I'll actually highlight the g function in yellow, and we can highlight the h function in green. Well, if I do the derivative, I simply have to take g prime, which is going to be 3, times the h function plus the derivative of the h function, which would be 2x plus 4, times the g function, 3x plus 1. And you could FOIL to simplify. And if we do, we get 3x squared plus 12x plus 6x squared plus 2x plus 12x plus 4. All of this comes down to 9x squared plus 26x plus 4. All right, so that's the product rule. And the last rule for today is the quotient rule. The quotient rule says that if I take any function that can be written as the quotient of two other functions, so g of x and h of x, then the derivative of this is simply let me make sure we get this right in the correct order. The derivative will simply be h of x times g prime of x minus g of x times h prime of x, all divided by h of x squared. So let's look at an example. Let's suppose that f of x is x squared minus 4, and g of x is x squared plus 3x plus 2. And let me highlight the two functions. H is in the bottom, so that is the x squared plus 3x plus 2 function. G is in the numerator, so we will call that the x squared plus minus 4 function. And now we can find the derivative. So first of all, the formula tells me to start off with h of x. So that's x squared plus 3x plus 2. And multiply that by g of x, which would be 2x, minus the g function, which is x squared minus 4, times the derivative of the h function, which would be 2x plus 3. And that's all going to be over the h function squared. Okay. This actually could be simplified, and I'll leave that for you to do, but it does simplify if we distribute the 2x to every term and we FOIL the second set of terms and we square the trinomial in the denominator. It can be simplified. But let's put f prime of x in a different light. Okay? Another way of thinking of g of x over h of x is a high function over a low function. Instead of saying high over low, we're actually going to say high over ho. And you'll see why here in a second. So f prime is going to be the same as ho times the derivative of the high function minus the high function times the derivative of the ho function, all divided by the ho function squared. Now, sometimes this is an easy device to use to help us to remember how to use the quotient rule, but it simply reads ho d high minus high d ho all over ho ho. I'll say that again. Ho d high minus high d ho all over ho ho. So if you can remember that little device, hopefully that'll help you remember how to use the quotient rule. Okay, thank you for watching.